Hey folks, it's Rob Flux here with another Sunday session, and today is a very special session. We're going to be talking about modern methods of construction, and there are many, many different ways to actually do modern methods of construction, but we're going to be talking specifically about panelized construction and systemization of our build process and pre-building in the factory in order to speed up the delivery timelines in the process. Now, in order to do that, I have a very special guest, Mr. Paul Adams from Assemble Systems. Hey, Paul, welcome to the show, mate.
G'day, Rob. Thanks for having me.
That's okay. So, mate, I guess this is an emerging industry in Australia, but I guess globally they've been doing prefabrication and modern methods of construction for over 40 odd years in Europe, and it's just something that's been very, very slow from a take-up perspective in Australia. So our job here is to try and take our people on a journey from I know nothing to I know everything about prefab, and we're going to deep dive into, I guess, the panelization and I guess systemization of things. But there's also lots of other methodologies we'll touch on as well. But before we do that, let's just give some people some background. Who is Paul? Who is Assemble Systems? Why are you the guy that we should be talking to today, mate?
Yeah, well, I run two businesses. One is a fabrication business called Assemble Systems, where we look at prefabricated panelized solutions, timber-based construction. So we focus on timber-based fabrication. Also have an architecture practice which provides sort of the lead-in and sort of consulting services which support the fabrication business. They are separate businesses. One we're talking about a lot today is Assemble Systems and some of the fabrication, but sort of understanding that there is every building project starts with a design service and an engineering service, and so we work in both those spaces.
So that other business is MODUS Architects. I've put your contact details with regards to that on screen, but you're in the unique position of, I guess, designing it and constructing it. So we can talk about some of the issues and challenges that people have in that process, and why, I guess, pre-planning of that is such an important part of the process. But tell us a little bit about Assemble Systems. That's what we're here to talk about today. When we say panelized, what is panelized?
So in the Australian construction industry, panelization, the way that we look at it is it's emerging from what might be known as sort of traditional truss and frame fabrication. So fabricators being wall frame fabricators, truss fabricators, floor truss fabricators. The space we work in is sort of a value add to that. So a floor posies could be sent out as individual sticks. What we prepare is floor cassettes, where you've got floor joists and bearers all put together as a group, as a cassette, as a system. Similar with wall systems, wall frames could be sent out, but what we do is wall frames, we add sheathing, add wall wrap, add battens, install windows, wrap them, and clad where possible. So what we're talking about is a wall system, which starts with a frame, but then has a whole lot of value add to it. And similar with roofs. So we look at roof cassettes rather than roof trusses. So we're talking about rafters and ridge beams put together as a cassette. So a panel which is put together as a group, and that has wrap on it and counter battens, and in preparation for a roofer to come along and put roofing on. So all of that is looking at from, say, a floor system, might be a slab, might be a suspended subfloor where we've provided floor cassettes, through to the underside of roofing. What we're providing and fabricating is the structure in panels, in sections, which then, when delivered to site and received by the builder and installed, would get the building to definitely frame stage, and then to advanced lockup and weather tight is where we focus on. So panelization really is looking at a building design or a floor plan, and breaking it down into its sections, fabricating as much as we can in the factory to then speed up the process of sort of achieving definitely lock up and achieving or weather tight and lock up as quickly as possible. And that being done in parallel with on-site work.
Yeah, now there's lots of different I guess prefab technologies that are actually sitting out there. So it's probably worth going back a couple of steps for people to actually go, look, prefab has been happening and is happening to some extent already, but it's really stepping up the game, right? So we're familiar with, I guess, people going and getting frames built off-site and just having a frame turn up. We're familiar with having kitchens designed and turned up as pre-built carcasses and assembling all of those sorts of things. But it's trying to, I guess, think of it as an end-to-end solution, not small piecemeal pieces, and go, how do we actually put all of this together? And that's really what modern methods of construction is about in and of its entirety. Now, there's lots of different things. So frames, trusses, kitchens, cabinets, panelization. There's volumetric. There's bathroom pods. There's, I guess, from an open framing perspective, and then there's the systems that you guys do, which I guess in the industry, they're starting to call it a kit of parts, where you assemble all of it in the factory, whether it be the roof, whether it be, I guess, the flooring system, the frames, etc., and then they assemble it on site a little bit, kind of like a Lego brick system, but everything's been designed with instructions.
That's, yeah, basically. I mean, what we're doing is in the factory, before starting to fabricate, you're doing shop drawings and you're modeling the building in its entirety. So with the structural engineer, who would have been the design engineer for the project, all of their specifications get integrated into a set of framing modeling, which then gets turned into shop drawings or fabrication drawings to then facilitate the factory preparing its system. So what you're doing is you're starting the integration of all of that sort of traditional on-site work in a virtual 3D model space, which is what truss and frame fabricators do, and what steel fabricators do. I mean, it's nothing different from how a lot of the industry works at the moment, but what we're looking at is sort of the whole of house, and then adding those layers really to create a system, rather than sort of each individual element sort of being done separately.
Yeah, and look, we're going to go and break it down into the individual elements as we go, but effectively, by building it, I guess, inside a factory, you're in a controlled environment. So the quality of the work, the consistency of the work, the efficiency of the work is going to be much better than doing it out in the weather. Now, I like to give this kind of analogy, and I'm going to exaggerate a point just to kind of, so I'm not picking on tradies here, by the way. But every tradie turning up, in the first thing he does in the morning is spend half an hour emptying his toolbox and bringing the tools on site. And at the end of the day, he has to also pack them up and put them back. Whereas in a factory, those tools are on the wall. He gets halfway through the day and he runs out of nails and has to go get some more. But in a factory, you've got an inventory that's actually got a supply chain management that kind of puts all of that stuff in. When he's out, I guess, in the weather, it's raining, it's too hot, it's whatever. So you're not always going to get 100% productivity all the time. So he's also doing it in a residential area. So what time he can start and what time he can finish are limited by noise. So when we start to do all of those things, to say, well, building it in a controlled environment, we can build whether it's raining or sunny or whatever. We can build at all sorts of hours. We can do efficiencies in our timeline, and they are 100% effective from day one. You just become more efficient. Then you start to then layer in your, I guess, design efficiencies that we're going to talk about, and then this is where these things start to really pay off.
Spot on. That's it. The ability to work in a controlled environment indoors and have all of exactly the supply chain management, making sure you've pre-ordered and you understand all the materials that you're going to need. They're all under one roof in one place. And I guess the more you can build into a system, a wall system or a roof system or floor system, the more efficiencies you'll get inherently in doing that all in just the one place. And the obvious weather-related benefits. You can run shifts. In theory, a factory can run 3 shifts, so they could run 24/7. And when automation and robotics and other things are part of a factory process, more and more can be done, and that does have efficiencies, but it also builds in. When you're looking at fabricators and manufacturers, inherent in a fabrication business is, occupational health, so OH&S and quality control systems have to be built into any factory. So what you're getting is the benefits to the construction industry of what a manufacturing process has to build into its workforce and its workplace. So
yeah. So and being super clear for everybody out there, this isn't about people losing jobs. It's about having the same job in a more comfortable environment and being more efficient and more effective at doing the same thing. So just kind of calling that out there up front. But look, in putting this together, there's a whole bunch of issues and challenges in the industry that I guess myths that we want to start to bust, and how do we actually start to break this down? One of the biggest challenges that I see is it comes from step one in the process. Every developer wanting to build an absolute custom bespoke solution that every site is unique every single time. And because it's bespoke, I guess, and they're not designing for modular assembly in the first place, called DFMA, it means that I guess there's no opportunity to go and use prefab because the builders have to do a bespoke solution every time. But if we go talk to our architect and say, hey, I want repeatability, I want consistency, how do we actually start to do this and systemize the processes? And we design that in from day one. We have to ask our architects to design for manufactured assembly, DFMA. And if they do, then when that comes to the builder now has choices. Do I use a traditional stick build, or do I start to use, I guess, some of these type technologies? Now, as an architect, where do you see that where we get this horribly wrong, other than just not asking for it?
I think there's the industry has some disconnects between what the capability of sort of manufacturing and production is. The disconnect between that and what the architect's capability to understand that. So there's the traditional process is architect or building designer, not just architects, so building designers and architects design a building. It goes, an engineer looks at it, goes, okay, this is the engineering to support your design. That then goes to builder to then put to trades to price. It's very sort of segmented and linear. There's not transparency between sort of the designer and the end sort of builder. Not transparency, but there's not an understanding of the relationship between those two things. If an architect were to understand that there's a fabricator out there able to put together this building, and started a conversation with that fabricator, and then in their role as coordinator of services and engineering and everything else, then we're able to then bring in a structural engineer and bring that engineer into the conversation with the fabricator. You then start to sort of draw the link between what can be fabricated and manufactured off-site, and then that loop can then go back to the architect where they can start to design a building suitable for fabrication. Obviously, in amongst all of that is the builder, the head contractor, who's going to deliver all of this. So traditional processes also look at tendering processes where you get a set of documents, they then go to a number of builders to tender, and those builders would then think about the fabricators. Now, how do you draw all those things together as a rather than sort of a linear process? How do you bring that all together in one? Now, that is a complexity around sort of competition in the marketplace, and how different builders would price a project. But that said, if an architect understood the capabilities in the industry and could point to those and design with an engineer a building that could be fabricated by any range of fabricators out there, us included, you could then see the sort of that link being drawn all the way through. So the potential for the take up of this I think really sits with the design end and engineering end of the project, where a developer wanting to develop would talk to an architect and talk to them about their engineering networks, or have an engineer involved, and then starts to talk also about fabricators and their capability, and then bring builders in to the conversation and talk about, well, how do we bring this all together, sort of before we even start designing it, because it all then relates back to the site, doesn't it? So
yeah, so it is the developer asking the architect to go, hey, I want to use modern methods of construction and I want to bring efficiencies to this because I want to get my project in and out of the ground much, much faster, okay, more efficiently, more effectively. But equally, it's the architects who should be, I guess, starting to think about this as a default to say, well, why aren't I designing for this day one unless I'm told otherwise? Because then my builder's got choices. Now they can do a traditional build if it's designed for manufactured assembly, but they can also do this alternative approach, which then by just changing the start and giving the builders the choice, then the builders are more likely to engage in, I guess, the prefab side of things, which means that the industry becomes more mature in that space, which then means the capability starts to build and we get even more efficiencies and more effectiveness in it. But it's got to start at the start. And we've got to start to ask for it. And while we keep going, hey, I want this, I guess, custom solution that doesn't even think about any systemization, we're always going to get the same outcome.
Yeah, or you've got to take a pretty big step to sort of redraw the design, or sort of go back and sort of review the whole project through another lens.
Yeah,
and so.
And it's too late to do that once the DA is approved, right?
That's right.
So you need to do it at the point before you lodge, folks, is kind of get that, I guess, as one of your first thought processes is, how do I, instead of taking 2 years to actually build my project, how do I get in and out in 12 months, 18 months, right? And we're going to touch on how that might be as little as 12 a little bit later, just with some of the efficiencies of time that these processes bring. But as an architect, what are some of the design faux pas that people kind of overlook when they're thinking about DFMA? What are the things to avoid?
It's this balance between sort of repeatable systems or repeatable sort of dimensions, and sort of there's a balance between sort of cookie cutter repeating the same thing, but then also the unique or bespoke nature of a build. And I think in the design profession, there's definitely a lot of pressure to prepare and present a bespoke solution that's unique, individual, and sort of very customized. And that might be an expectation from clients, it might be an expectation from town planners, but the balance that has to be struck is around achieving something bespoke and unique and interesting and wonderful and good for the end user and great for the client who's the developer, but also using an approach that is efficient and streamlined and affordable. And when I say affordable, it's the right cost, no wastage and no sort of extra cost spent. So I think that the lack of sort of knowledge around how to achieve that in the industry is probably the problem, and a lot of focus on sort of bespoke and one-off can sort of lead to an inability to sort of transfer that into a sort of efficient and streamlined build.
And I guess to that point, a project that I'm currently involved in, I guess we've got 17 townhouses in that with 4 different floor plans. But the repeatability and consistency, there's 2 bedders, 3 bedders, 4 bedders, and 5, but there's about 80% of that is repeated design elements. That still gives the uniqueness to give all those different flavors and variations, but it's really about designing for it to go, hey, how do I how do I have the same kitchens, but maybe different colors and palettes, and maybe even different materials, so it looks different, and the same walling systems and the same window systems, but a 2-bedder and a 5-bedder with 80% of it the same actually looks completely different.
Yeah.
And I think a lot of people kind of forget that you can have the repeatability without it looking like, I guess, a photocopy.
That's right. Another element is sort of integrating structural, or understanding the implication of the design and working with structural engineers, which then, if you're also working with a fabricator, but even working directly with a structural engineer to understand sort of load paths of the building and where to put walls to create sort of efficient construction, which is universal, whether you're a fabricator or not. Efficient buildings are efficient regardless. So sort of there's a bit of a cultural, not disconnect, but there could be a more integrated sort of work between architect and engineer, say, and then by that extension potentially fabricators, to just to understand how to make an efficient building.
Yeah. So that said, we've got our architect to design for modular assembly. We've, I guess we're, coming to someone like yourself or others to say, hey, how do we actually start to roll this out? When we say kit of parts, when we're pulling a house apart into the parts, what are the parts that we can actually genuinely pull apart and basically flat pack our house and deliver it to site?
So I think, as I said a bit earlier, the main sections of the house that are panelized or can be panelized through our process and others is floor cassettes, wall frames or wall panels, and roof cassettes. At the early conversations with, I guess, developer, landowner, is about the site, the constraints around the site, what the shape and size of the site is, what are the access requirements, how do you deliver anything to the property, can you get a semi-trailer in or a truck, or what size crane you're going to need. So there's a whole lot of sort of thinking would go on early on to say, well, what are the site constraints? If something's going to be delivered here as a modular or prefabricated, panelized, or kit of parts project, how will it be done? So that's got to go into the conversation fairly early on. What's the brief? What is the expectations in terms of yield, and what, how many townhouses or buildings are going to be needed to be accommodated on the site? So understanding, what site coverage there will be, and then you look at access, what potential access there are. So that's a conversation that has to happen, because that leads into, well, if something's going to be fabricated, what size and shape are we fabricating? Are we doing it as little modules? Are we doing it as flat pack panelization? Assuming we get to the point where flat pack and panelization becomes a solution, you're then looking at, well, okay, what we want to do is have minimal lifts of panels off a truck into place. So to get minimal lifts, we want each panel to be as big as possible. That's the approach that we would take, right? So if you could build one whole 20-meter long wall by 2.4, 2.7, if you could build that in one go, imagine lifting that off a truck and landing that in one hit, you're really winning, because you've got the size of a truck will influence what you can actually make and transport, and the weight and load. So we start to break it down like that. But the overarching emphasis is on efficiency of lifting, efficiency of getting something off from the factory onto a truck, and then the builder getting it off the truck into place. So we'd be looking at kit of parts panelization as bigger sections as you can do in one go that the factory can accommodate. So typically that might be a 6-meter long wall, up to 6-meter long wall with, a height depending on the floor-to-floor levels, and floor cassettes sort of as wide as you can for a truck load and as long as you can for the structural requirements. So it's just breaking it down into those kits of parts, because what you're trying to do ultimately is minimize your time on site, offload into place, builder takes it into place as quickly as possible. So the less lifts, it means less panels means less lifts means quicker install time, and then moving from delivery to that next stage of the project as quickly as possible. So,
and when we say quicker, like let's give some context here. So from slab being poured to a house at lockup, remembering these panels are turning up with windows and doors and everything already installed because they're an entire system. If we just did one house, how quickly can we get start to finish to have lockup?
I mean, a week's a reasonable amount of time. I mean, at the end of the day, what we're minimizing or helping the builder minimize is how much time they're spending installing the panels. So we would say 5 to 7 working days would well and truly cover it. In a lot of ways, it's not a lot different in timing from what a frame and truss might take to erect. It's just done with lifting equipment, where each panel gets done with a crane truck or a crane. The time-consuming element
watertight with a roof and effectively lock up. So,
we'd say weather tight, because you still have the roof has still got to be scheduled. But if you could get the roofer scheduled to come that next day, there you are. You've got lock up in a week.
So from a builder's perspective, his cash flow is going to be much better, because that's one of his major milestones is a lockup payment. So from a project management perspective, if he can, I guess, roll that out faster, 65% of his payment is paid at that point. Then he's just got the internal fit outs to actually do. But we're at a point where with a really good team, and we start to design the other internal elements to go inside, design them, I guess, to be assembled in similar ways, then they can effectively start rolling these things out super fast. Now, I've seen examples using systems identical to yours, but where they're rolling out 12 townhouses in 51 days from slab poured to key handed over to the owner. 51 days, 12 townhouses. Right, that's what we're talking about from an efficiencies perspective, folks, is to say, but to do that, the builder has to think differently. So the order that I guess the trades turn up and what they're doing at the same time, they're not locking in a trade to turn up and do one rough in for one townhouse because that's the one frame that's there, but they're rolling in and rolling out, I guess, half a dozen trades, and he might do 4 townhouses and then roll into the next one, those same trades. So they're getting through very, very efficiently. So everybody's in and out faster. So
that's right. I mean, the other sort of inbuilt benefits in that efficiency or that timing side of things is the integration of the engineering and the shop drawings, and bringing in certifiers and inspectors into that early pre-construction phase means that any queries around I guess connections that the inspector would want to see at frame stage, they'll be brought up early on. So what will happen is that when the product's delivered to site, builder installs, calls up the frame inspection, what you will see then, because everyone's been involved before that, the traditional pathway of sort of inspection, then coming back with a whole lot of rectifications or queries that need to be resolved, a lot of those should be eliminated at this point. So the downtime of waiting for a re-inspection or waiting for a contractor to come back and sort of redo something, a lot of that is eliminated by everyone being involved in that sort of oversight of getting to frame stage and getting to lock up. And these are just the little pieces of efficiencies that all add up in the end to quite significant amounts of time.
Yeah, and being clear, what you're doing isn't any different to a normal build. It's the order that you're doing it and the efficiency that's actually coming in. So we're front loading the effort. So putting the effort into get it right before you actually start constructing and getting all that design engineering done perfectly, as opposed to out in the field going, hey, it doesn't quite fit. What do we need to do to kind of tweak it? And like you said, the rework that comes is associated with that. So by doing that front loading, you kind of framed that in a really good way the other day. I guess a side benefit of this. So I'll let you kind of throw it out there, because I won't do justice to how you said it. But the side benefit being the efficiencies that come.
Yeah, so you've got you're looking through a lens of, you've got to make a whole bunch of decisions around the final building really early on in the process. And what you're then doing is you've got a discipline applied to the whole project before prefabrication or before any fabrication starts. And what that does is just accidentally solves a whole lot of problems right at the beginning. So projects that sort of that have potential to stall along the way because a problem arises that wasn't foreseen, or waiting until you come to the problem before you address it, by sort of working in the fabrication side of things means you've got to shop draw and fabricate and integrate. The structural engineers design, the builders set out, the levels, everything has to be thought about in the virtual space in terms of 3D modeling and shop drawings. That all has to be decided, and that means a whole lot of decisions also have to be made. What size are the windows? What are they? Who's supplying them? How much are they going to cost? That's all got to be done earlier. You've then got the walls have to be moved with windows in them, so they have to be square and true and straight. Our fabrication
windows have to be ordered earlier, and
yep, that's it. They've got to turn up. We can't start making. We won't make a wall system without the windows there, because it's a system. You don't make a wall and then put a window in. You make the wall, install the window, and finish that wall system as one go. So it's these inbuilt efficiencies that happen. The accuracy and every wall has to be square and straight before it's shipped. I mean, we can't move it, because if you put a window in and it moves, it doesn't. The thing doesn't work. So then you start from the slab or the ground floor, making sure everything's level. So then you don't have issues with having to straighten, as many issues with having to straighten walls, or definitely not sort of move frames to deal with slabs. That all gets dealt with day one when the builder installs. So it's just these sort of incremental efficiencies that just get and quality control just gets built into the process. So then you've got less potential carpentry time on site. Definitely can be reduced if you've got less wall straightening to do. You've got less. Anyway, it's sort of, because that's all been dealt with. Yeah.
It's all been dealt with. So and I guess that's going to flow through everything. The whole project management side of things, the order of things changes. So the what doesn't change, but the order does, because we're front end loading that. So like you said, you've got to order our windows before the frames are there, not after. Which means that you've got to think ahead. What are those windows and what are those sizes? Now they should already be, I guess, part of your original DA drawings and know what they are. But it's, what color anodized aluminium am I going to do, and which manufacturer I'm going to get it from, and like it just brings that project management efficiency, as you said, becomes a discipline, which then rolls out to some of the other decisions that, in a traditional build, sometimes people aren't even deciding what color am I going to paint the bloody thing. They're not even making those decisions early. Now they're going to have to, because it's going to be ready so quick. And so when you start thinking efficiently at the start, then all your other decisions at the end, like what color taps and style of that, it all starts to just roll out.
That's it.
That's
it. I mean, you touched on earlier around sort of efficiency and but also a balance around customization. So your example of townhouses with all the same floor plan, but maybe different color scheme.
Floor plate, yeah.
Floor plate, yeah. But they doesn't mean you can't have different tiles in each of the bathrooms. You can't have different benchtop colors. So customization, even different colored cladding. The customization can still be there. It's not like we're saying you have to have just this. You can have some customization, but it's how it's how the discipline around how you come up to that point, if that makes sense.
And it's more to the point. It's picking that off a catalog. So, okay, so if you're going to a tile supplier, for example, they've got a catalog of tiles within that. So you're going to pick from that. You're not going to get some sort of tiles from one tile guy and another lot of tiles from a different tile guy. You're generally going to get them all from the one supplier. So if you know that they're always going to be 600 by 600 tiles, it's just what color, right? Pull it off the catalog and go, well, we can customize it, but what colors are going to be? And you just apply that discipline to everything. So is it a square basin? Is it a round basin? Is it a silver tap? Is it a gold tap? So you can walk into one house and whilst it's going to be a very similar floor plate, it's going to have a completely different feel to it because you're customizing the palette and the I guess the nuances of the fit out.
Yeah, that's it.
Yeah. Now, I guess we talked a lot about the pre-design side. In order to do that preloading of that effort, rather than doing it on site, we're not really changing what effort occurs. We're changing when it occurs. So just give us some insights into, I guess, once they've given you some, they've got some DA approved drawings and they come to yourselves. What's the process and the timeline before you can actually start the process of actually manufacturing?
So just straight, if we had a external team come to us with a set of drawings to the fabrication business, we would, if we hadn't been engaged earlier, what we'd want to do is just review the documents that were put in front of us from the, let's say it's DA documents. We would then be able to say, well, if you want us to price or give indicative costings, what you need to do is we need some engineering advice. We can look at the architectural overview because we have capabilities in that space. And then we'd be looking at what the sort of the broad scope of the panelization, what it would be and the suitability of your project for our setup. Ideally at that point, you then sort of, if we get commission to go ahead, if the sort of broad pricing looks about right, for us to get started, basically a set of documents, design and engineering and building permit or building certificate, construction certificate documents need to be ready, issued to us, and then we basically start drawing together the architectural and the structural into fabrication design, bring the engineer into the process because they'll be part of verifying the suitability of our system with their design. And then we basically get on with...
So how long does that stage take?
So we try and run things parallel as well. So what we're doing is if a building permit's issued and we've been signed up to do the work and the costings agreed to, which we do need a decent level of, we definitely need the architectural, structural and finishes schedules ready for us to be able to give a price. Fully documented obviously means the price is locked in. Sorry, I just lost my train of thought. The process at our end for can you just take me back to what
the design and shop drawings, mate?
Yeah, sure. Sorry, I jumped ahead a few steps. Where sorry.
I'll ask the question again.
Yeah, just ask me again.
I'm back on track. It's all good. So I guess once you're ready to pull the trigger, I guess in order to draw, before you actually start the manufacturing, just the design and shop drawings, you've got all the pre-work done.
Oh yeah, sorry. Yeah, I know where I was. Yeah, so we're running everything parallel. So what we're doing is we'd be ordering the windows at the same time as we start integrating the structural and the architectural and the framing. So we'd be starting to draw shop drawings. We'd be ordering windows. We'd also be assuring that we had the supply of materials in place. So what we're doing is running all that in parallel. So when the windows arrive, for example, we're in a position to have done shop drawings, integrate the engineering, have that checked by structural engineer that that's all suitable, and then we can hit the floor and start fabricating. And in terms of program, we would have talked with the builder and the developer about, okay, how many townhouses is it? Let's say, what order, what's your sequence of how you want to do this on site? Are you going to do this in groups of 4, or you're going to do it all as one hit, or you're doing one at a time? What's your on-site strategy? So, or procurement plan. So that's a conversation with the builder. So we then start basically retain our accountability to the builder's program, but we want a conversation where it goes back and forth to say, well, how long will it take you to do this many? How long will it take you to get the site established and ready? And then we start to roll out a plan for how we would fabricate to match in with the key milestones of the builder's program. Because what we're focusing on really is eliminating downtime on site. So our capability measured in with the builder's site program, if they can be running where we're hitting the milestones on site to eliminate any slowdowns, then we're winning. Basically, we're doing our job right. We probably don't want to see is a builder do 20 house slabs and then say to us, get started now. That doesn't make a lot of sense. And we say, well, we can only do 1 a week, and it's going to take us 20 weeks. So then everyone's waiting for 20 weeks after the slabs are down. That's not using us effectively. Working with us to match in with, or any other fabricator for that matter, and different fabricators have different capabilities, and
So you don't want to be rolling them out one at a time and that sort of thing. You want to be able to say, right, all the same ones are in the same batch, so that we can actually get some efficiencies. Now, you touched on about 5 days to roll out a single dwelling, but if we rolled out 10 dwellings and we design the batches correctly, you're going to get a lot more efficiencies of actually doing that.
Absolutely. And for us, it's about pre-planning as well. So if we know what's ahead of us, we'll plan it to be as efficient as possible at our end too. So if we've got repeated wall panels or repeated floor cassettes, we might decide to make them all in a batch and have them sitting ready. And that's us. The agility at our end is just to make sure that we're working in with what the program on site is and what the designs are. So we'll make those decisions for ourselves about what we think is the most efficient way to meet that.
Which means that going from 1 dwelling being about 5 days or so to rolling out 10 dwellings might be, in your factory, might be 7 to 8 weeks, as an example. Mm-hmm. All of that happening, I guess, before you actually get to site. Now, at the same time, like, everything's in parallel. The builder is actually doing all his site prep. He's putting all his civils in. He's doing his slabs down. So all of this stuff is happening in parallel, not in series like it would in a traditional build. So effectively, when you get to site, it just goes up, right? It's not a huge delay from that side of things. But what does that bring from an efficiencies perspective? So obviously, time on site is, I guess, from start to finish of a project is one part. Traditional stick builds are taking 12 months to do, a 6-pack of townhouses. But I gave the example before, 51 days to do 12 townhouses with a builder that's efficient and effective at actually rolling these things out. But what other efficiencies come? So it's not just the time. What else comes?
I think, waste is something that definitely is a key element to doing anything off-site. Anything that's part of our system we deliver, we manage all that waste in the factory. So there's waste management, offcuts, all of that sort of, each different fabricate or each different trade and what they would bring to a site in terms of sort of wastage of materials. We've got all of that. Well, we're responsible for all of that in our off-site facility. So waste management is I think a huge one that impacts on how the site's managed as well. The sort of time efficiencies we've definitely talked about. The
So a big one,
the shortening of all of the shortening of all of the time needed to do each of the. So scaffolding's a good one, so scaffolding's needed for obvious safety reasons, but maybe it's only needed for a week rather than a month. So what you then is just collapsing all of those requirements. So if we've pre-clad 80% of the building, then scaffolding might be needed for doing corner connections and finishing off areas, or doing bespoke elements, but that's down to a way shorter period of time, maybe days rather than weeks or months. So it's those incremental sort of, all of those efficiencies all build into a bigger picture of efficiency. So
and then there's the quality of the things, like you said, the walls are straighter because it's built in a so there's no need to straighten up on site. So then that's time savings and those sorts of things that come to the process as well. But I guess the long and the short of it, when you combine all these things together, it's holding costs. By far the biggest saving is holding costs. Now, I'd argue not a huge amount of saving in the actual cost to construct, right? It's just really moving, I guess, how and where the payments come. The actual cost to construct doesn't change, but the holding costs massively dropping what my interest rates are, or how much land tax, how many rates, what all those sorts of things, in and out of the market in the same period. So predictability of that. I guess the risk of a builder going broke because he's building so fast, he's not in a deal for 12 months and have another project take him out. There's so many knock-on effects for the builder themselves. They get their lockup payments heaps faster, so their cash flow in their business is better. And they finish their projects faster, which means they can roll out more projects and be more profitable as a business, which has a double whammy, because now I'm even less concerned about them going under, because now they're way more profitable. Yeah. So the benefits here are almost exponential. Like, have I missed any of them?
No. I mean, it's sort of efficiency. Quality gets inbuilt just because you've got to have a better process. You've got a process around quality. Time waste, sort of energy efficiency, and sort of some of those materials efficiencies. That gets also sort of built in as well. It's a tighter building fabric. So if you've got a customer base which has expectations around sort of performance buildings, or the construction code, which is increasingly getting more rigorous in terms of its expectations around energy performance. Things like glazing, which is, if double glazing, large sections of double glazing becomes more prevalent in buildings, these are heavy elements. They have extra equipment required to install glazing. That all gets built into the process around sort of the fabrication of the wall system. So you get all of these sort of, as quality expectations increase, it becomes more, I just think, more beneficial that this stuff's being done off-site in a fabricated environment. And the industry is moving in that direction. So, with regulators being far more scrutiny on, waterproofing, and you've got sort of the risks that occur to any build site around tradies being on site and sort of defects happening, or defective work happening because of accidents on site. The more you've got this sort of in a controlled environment, the less chance of that is. I'm not saying it's eliminated. The builder is still responsible to hand over a building and inspect it all. But the more you take away from sort of the on-site sort of fairly, I'd say, so many different tradies being on site and coordinating all of that does add an element of risk to the builder's end product. So it's just helping to manage all of that. So
and also the ability for tradies to come in and start and finish their work, rather than having to go do 80%, go away, come back, go do another job in between, get tied up on that job. It's all of those knock-on effects that happen, especially when you're starting to roll out multiple product in the same project. the tradies rolling from one dwelling to the next dwelling to the next dwelling, and they can be in and out much, much faster than they would be if you're building some of it today and a week later building another some of it. And so I guess these are all compounding benefits, which really adds up to holding cost savings, and which makes, in the end, the deal more profitable and less risk.
Yep, that's it. It's a risk management strategy. I'd say it's a quality and risk management piece of kit of it's part of the procurement sort of process, and this is one of the elements that can be brought in along with everything else that's needed. This is a strategy that can definitely assist. You know, it's not a silver bullet, but it's definitely can help.
No, I think we've given it I guess the appropriate plug, mate. So if we were going to give it one tip, if you were going to give somebody the biggest tip in how to I guess use, whether it be panelized, volumetric, or whatever modern method of construction, what would be that one tip, mate?
Look, I think just getting as many of the players in the room as you can at the beginning of the project. So when I say the players, I mean from the design phase through the engineering, builder, and fabricator. Get all of those into the room at the beginning of the project and work out a strategy on how you're going to deliver it, work out a strategy on what the cost is going to be, but do that with all of those. I mean, do the research on who. Don't just assume anyone can do it. Find out who's got the capability, and bring them together at the beginning before you strategize. I think that's the key.
And for me, my one tip, folks, you need to be asking your architect to design for manufactured assembly. That is DFMA, so that everything is thinking about, I guess, systemizing this from the very, very beginning, so that efficiencies can be brought in the manufacturing process in a whole raft of ways. But if you do DFMA, then your builder now has the opportunity to use prefab if they want to. They can still do a traditional build. It's not eliminating that, I guess, possibility, but they have that as an opportunity, which then means that they can then take it to people like Paul and say, hey, mate, we want more of these. So the industry is going to grow, which then means that we're going to get more and more efficiencies in that process as we start rolling out more things. So this is just the tip of the iceberg, folks. I was at an industry briefing the other day. We're doing less than 8% of our project homes, of our builds at the moment, have some form of I guess prefab involved. That's largely just pure frames and kitchen cabinetry at the moment. But we want to start rolling this out through a lot of our systems, folks. And when we start to do that, things will go really well. You just flipped and went backwards there, Paul. I don't know what happened there, but and he's back.
I don't know.
All good. So, folks, I hope you've enjoyed the show. Just give you some insights that not only do we run these YouTube channels, but we also run physical events all the way around the country. So we run them in Brisbane, Sydney, Melbourne, and Adelaide. We get experts like Paul to come in and talk about different issues and challenges and problems you're going to have in your industry. Plus, we get members of our community sharing real deals, so you get to learn from the success and challenges of other people's projects. So hoping to see you at one of the upcoming meetups. Paul, been an absolute pleasure, mate. Thank you very much for your time. And folks, we're going to say see you next time. Bye for now.